Well, welcome everybody. As Joe said, my name is Kate Laramie. I am a watershed ecologist with the Huron River Watershed Council, and I am a new addition to the CLMP program management team. So really looking forward to getting to know a bunch of you over the course of the next several years. It's just a picture of me falling over in a cattail marsh, as I like to do during the field season. Okay, so let's just dive right in, talking about Secchi disk transparency. As you know, Eric already mentioned, Secchi disks are a really simple tool, but they can tell us a lot about lake ecology by telling us about how light moves through water. So how transparent is our lake? So I like this image here. It's a pretty drawing that helps us understand, as light is coming through the top of our lake here, filtering down through the water column. It's impacting the ecology of that system and how well different plants and animals can grow and thrive in that lake. First off, what is a Secchi disc? A Secchi disc is this very simple 8-inch disc. It was developed by an Italian scientist back in the 1800s who was interested in understanding the transparency of the Mediterranean Sea. We still use this very simple technology today. It is I would say, our easiest parameter to monitor, but like I said, it can still tell us a lot about lake ecology. So it's a really nice one to sign up for, particularly if you're new to the program and just really looking to get your feet wet in scientific monitoring. These discs are two colors, they're black and white. We got a question at the in-person training earlier this week, which I thought was really interesting, about whether folks who have color blindness or different issues with color acuity can still use a Secchi disc. Yes, they can. That's the benefit of just the two-tone part of the disc being the primary thing that we're looking at rather than a difference in color. So how does it work specifically? So Secchi discs are dropped down into your lake off the side of your boat. And there are lots of things in the water that can make it challenging to see down through the water. Water color to start with. So if anybody's ever been up to Tequamanon Falls in the UP, that's my favorite example. It's called the Root Beer Falls. That water is very dark brown. And that's due to a natural processes, tannins that are leaching from the trees and plant material up there into the water that are actually changing the color of the water. So natural and unnatural, but there are lots of reasons that water color can change naturally and can impact our ability to see down through the water column. And then algae. Algae is a big one that I'm sure many of you are interested in, that we're monitoring, through the CLMP program. And Secchi disk transparency is a really simple way to see how transparency may change as you have more algae growth in the water. So you can see in this image here a lot of cloudy water that could be caused by these little particles in the water, like algae, or also particles like suspended solids. So this could be sediment, so actual dirt in the water, organic material that can get kicked up and churned up into your lake. And that can really impact the ability of you to see through the water and light to get through the water. Okay, so what does transparency tell us other than it's hard to see through the water? Well, as Eric discussed already, these different levels of nutrification in a lake. So a really eutrophic system, a system with a lot of primary production. You have a lot of growth happening there, often of things like algae. That's going to be water that's harder to see through. So as we are doing our Secchi monitoring, we can say, are we seeing changes in the amount of what we think is the amount of nutrients in a lake over time because the transparency is declining, maybe due to algae. Also, very oligotrophic lakes, so lakes that have very low levels of nutrients generally are much clearer, easier to see down through. So we can really glean a lot from this very simple tool about what might be going on with nutrients in our lake. We can also learn a lot about what we call browning. So in this image on the far right, you see a lot of sediment coming into a lake from a river system. So our Secchi disk can tell us about whether we may be having issues with excess sedimentation, erosion, other things being kicked up in the water column that could impact lake health. And then also, as I mentioned, there's lots of natural reasons why it may be challenging to see down through the water, like water color. So just understanding what our Secchi transparency is like and doing monitoring over time is really important to establish that baseline, see where is our lake naturally and whether or not it's changing. So monitoring water clarity through a season is really important. So as I mentioned, algae growth and nutrification in lakes. we often see a reduction in transparency in July and August in many of our lakes. So if you look at this graph on the vertical axis on the far left, that's our Secchi disk depth. So 0 is the surface of our lake where our little boat and fishermen are, going down in this example to 25 feet on the left there. And we see that our transparency in May is very good. We can see down probably to 17, 18 feet down into the water column. That transparency gets worse and worse, so it gets harder to see through the water as the summer progresses. Then it starts to improve again in the fall. And this is a very classic pattern that we see mostly due to algae growth, which in many of our lakes, that's a very natural pattern. Water heats up. We start seeing more growth of these little plants and algae that are able to grow under warmer conditions. And then we see a reduction in water clarity. So monitoring through a season is really important to start tracking just natural fluctuations in our transparency that we see in our lake throughout the year. But then also, as Eric mentioned, it's just as important to measure over time, year by year. So here we have 3 different graphs lined up. Again, our Secchi disk depth is on the vertical axis on the left. So we've got our little person in a fishing boat there. We have surface level at 0, and this graph drops down to 30 feet in depth. And now we're looking at not only changes in season, so May through September, but also comparing different years. So on the far left, we have monitoring May through September in 2020, in the center, May through September in 21, and on the far right, May through September in 2022. And we start to see by monitoring over time whether or not these changes in Secchi transparency that we're seeing from May through September are occurring every year, or whether we maybe find in a certain monitoring year that something strange is going on. Maybe we have reduced water clarity in May. And by monitoring over several years, we can say, okay, that is a discrepancy. Maybe something's going on. We want to continue to monitor to see if that change continues. So here's just another way to visualize very similar data. So now we have averages in our Secchi depth over many years. So monitoring started on this lake, this example lake, in the 1970s, kind of monitoring on and off, but then really consistent through 1984 through 2013. And we're starting to see, how maybe patterns are emerging in our Secchi transparency, averaged across each of those years. And that allows us to then make some larger inferences and better understand how this lake may be changing over time. We've also lined up over this graph those different metrics for whether a lake is eutrophic, so it's got a lot of nutrients in it, a lot of primary production, whether it's mesotrophic, somewhere kind of in the middle, that's a lot of our lakes, particularly down here in Southeast Michigan, or whether the lake is oligotrophic, so it has very few nutrients in it, very little growth happening. Generally, this is very, very clear water. So we can see even in the same lake, we may have different years in which our lake is registering based on our Secchi data in these different trophic categories. But by monitoring over time, we can say, okay, are we seeing an overall decline in transparency year to year, or are we just seeing some variability, one year after another? Just to look at some specific dates here, I like to note, if you compared 1984 to 2007, you may say, okay, this date or this lake is very stable. We're seeing very few changes. Versus if you compare 1984 to 2013, you may say, wow, transparency has really improved over time. But then if you look at all these years together, you can say, wow, this really bounces up and down a lot. Seems like maybe overall it's pretty stable by looking at these patterns. So this is really just to emphasize why long-term monitoring is really important. And we don't, at the CLMP, we don't make broad statements about what our data can tell us about lake health with only just a couple years of monitoring data. Okay, so let's dive into the protocol. How do you actually collect this data? This is just another graphic to view actually what you're doing. So you're going to be using very simple tools, including your boat. We're going to be dropping our Secchi disk off the side of our boat, and we're going to be looking at it through the water to see how well light is able to move through that water column. A few specific things to keep in mind. We want to eat. We want to evenly space our monitoring from the middle of May through the middle of September. As I said, this is really important to understand patterns, those seasonal patterns and transparency in our lake. We want to make sure that we're taking at least 8 measurements. So that looks like a measurement about every other week, middle of May through middle of September. So we want to evenly space those measurements as much as we can. If you'd like to go out every single week, I say that Secchi Disc is a great one to go out on a Saturday. You're planning to go out on your boat already. You've got your cooler, your friends are with you. And while you're out hanging out, maybe every Saturday, this is something you do on your lake, take your Secchi Disc with you and take that measurement. So you're welcome to do more monitoring, but you only need 8 measurements in order for the data to be, for us to be able to analyze the data at the end of the year. So this is what your data sheet looks like. So you can see here we've got our weekly sampling intervals in this column on the far left. So, when I say evenly spaced measurements, you don't have to go out exactly every 7 days or exactly every 14 days apart, always on a Friday. We just ask that within each, let's say we've decided to go out on May 18th, so that's within that May 14th to May 20th interval. Our date sampled is May 18th because that's the actual day that we're out there. We're going to write down the time of day that we're there. I'm going to talk a little bit more about specific times of day that we'd like you to monitor. It's a wide range. But we're going to write down exactly when we were out. And then we're going to write down our Secchi disc measurement, which we'll talk about exactly how to take that measurement in a minute. We want you to note weather conditions. These are very broad conditions, whether it was sunny, cloudy, windy. But then we'd also like you to note whether there were any unusual conditions happening on that day. So if there was heavy rain the day before, that heavy rain can really kick up a lot of material in your lake. It may reduce transparency. So we would like to know that. If there's a lot of heavy boating activity happening, even if it happened maybe the day before you were out monitoring. An example I like to give is 4th of July weekend. There's usually a lot of boats on lake churned and kind of kicked up. It's okay if you're still monitoring then. We do recommend that you don't go out on a really heavy boating day if you can avoid it. But if that's when you happen to be out monitoring, or if, like I said, the day before there was a lot of activity, just make sure to note that under unusual conditions. So if we see some weirdness in your data, we can then go back to this data sheet and say, okay, maybe that's why we're seeing a reduction in transparency on this particular day. At the top of our data sheet, we just want some basic information about your lake. So your lake name, the county and township that you're in, your lake sampling field ID number. I saw some questions about this in the chat. If you're not sure what your field ID number is, the easiest thing to do is just ask us. We assign a unique number to every lake that you'll carry through if you've monitored with our program in the past. The latitude and longitude of exactly where you're monitoring in the lake, I'm going to talk more about that in a minute. And then the volunteer names. If you're out with like a bunch of your grandkids, for a particular day, you don't need to write all their names down, but who are the main folks that are monitoring consistently? So that's probably you since you're on this training. Just write those names down. And then if we have any issues with your data, we can circle back and clarify that with you. Really important to note under unusual conditions, if your Secchi disc hits the bottom of your lake, if you're in a really shallow lake and you hit the bottom, that's okay, that can happen, but that's not a true interpretation of how far light can travel through that lake because we're impeded by the bottom of the lake. So always note if your Secchi hits the bottom. It might happen all the time, but it may happen periodically if you have a particularly clear day and your Secchi hits the bottom before you lose sight of it. Just another thing to note about why we like to take 8 measurements spaced evenly through the summer. We may just look at water that's getting a little green, a little brown and say, oh, it looks like there's a lot of algae growth happening. But algae are a really diverse group of organisms. You can see here on this graph, diatoms, green, blue-green, nanoplankton. These are all different types of algae and creatures that live in our lake. And they tend to grow at different periods of time, depending on their life cycles. So that's another reason that we like to take 8 measurements spaced evenly throughout the summer so that then if we're starting to see kind of interesting patterns and when transparency may be improving or declining, we can maybe attribute some of those changes to different growths and different types of organisms in the lake. Which, as I said, is generally very natural, and we want things to be growing in our lakes because otherwise they'd be just dead pools of water. Okay, so how do you specifically do this? We want to be drifting our boat approximately over the deepest part of our lake. So when you sign up to monitor with the CLMP program, if you're brand new, we help you identify the deepest point in your lake. So we give you that latitude and longitude of where you want to go. We ask that you do all of your monitoring, basically, except for a few other parameters where you're closer to the shore, but all of your monitoring over this deepest point in the lake. And that allows us to have consistency in our data collection so that if you're seeing changes or oddness happening in the data over time, we know that it's not due to you monitoring different spots of the lake because we're always in the same location. So we want to drift our boat approximately over the deepest part of our lake. Oh, here we go. This is exactly what I was saying. So if you want to go on MiCorps.net and take a look at your latitude and longitude and your field ID yourself, you can do that. If you're having trouble figuring that out, just send us an email and we can send all that information to you. But we identify this point looking at bathymetric data, so the topography at the bottom of the lake and other information, so that we make sure that we're finding that deepest point. All right, so then step two, once you've got your boat approximately where you need to be, on the shady side of your boat, you're going to slowly lower your Secchi disc into the water until it fully disappears from view. So you're going to drop it over the side of the boat, and then there's going to be a measuring tape attached to your disc, and you want to note the mark on the tape at the top of the water, so not like up in the air where it's easily readable from your boat, but what's the mark on the tape at the surface of the water when you can no longer see your disc? So in this example I put up here, we've got 15 feet. This is a really fun activity to do with several people, particularly on a Saturday if you're out there with your cooler and you're hanging out on the boat, and you can all debate whether you can still see the Secchi disc or not. It's totally okay if your grandkid is like, oh, I can see it, and it's 17 feet down, and you're like, I can't see it anymore. So long as you're within a foot or so of each other, you all can debate which is the number that you want to go with. So once it's disappeared, then you're slowly going to raise your disc back up until it reappears. So often this number is generally very close to the first number when you were lowering it down, but it's usually a little bit different. So you're going to pull that disc back up, and then you're going to note that number on your tape. So in my example here, that's 13.5 feet. And then the official measurement that we want to write on our data sheet is the average of those two depths. So what we're going to do is we're going to take 15 feet, the point at which our Secchi disappeared, 13.5 feet. This is all in my example. 13.5 feet, the point at which you could see the Secchi again. And then you're going to add those two numbers together and divide by 2 to get an average of 14.25 feet. Now we ask you to round to the nearest half foot. So in this example, I rounded to 14.5 feet. So this is just important to note. You don't need to be splitting hairs between an inch here and there, because we do ask you to round to that, nearest half foot of whatever measurement you're going to go with. Few things to remember. Don't wear sunglasses when you do this. Polarized sunglasses are wonderful. They're great for fishing. They're great for recreating, but they help you see through the water. And we don't want to make it easier for us. We want a true natural understanding from our natural eyes in our head, how well we can see down through the water for consistency in our data collection. So take your sunglasses off when you're doing this. As I already mentioned, pick the shady side of your boat. It's a lot harder to see down through very sunny water with that light's reflecting back up off the water. So pick the shady side of your boat to drop your Secchi in. If you can't figure out which is the shady side, if the sun is directly above you, don't stress about it. But do try to not drop your disc right in a big reflective sunny spot off your lake that you can barely see through. Be consistent in weather and timing. So we ask that you measure sometime between 10 a.m. and 4 p.m. when you go out. So I think that the example I gave earlier was, say you've picked May 18th. Say you go out at 2 p.m. We ask that you try to go out at 2 p.m. then in future, or right around there. The reason is, the sun is in different areas of the sky throughout the day. It hits the water at different angles. So our most consistent data is if we can go out, within a few hour window consistently every time we're out on the lake. Don't go out before 10 a.m. Or after 4 p.m. That's when it really gets harder to see based on the angle of the sun in the sky. So really that midday, that's why I say this is a great Saturday boating afternoon activity. Um, Sunny, calm days are best. We ask that you please don't go out on really heavy wind days. As I mentioned, if it was really windy the day before, that can still affect your reading, and that's okay, but that's why you can write that unusual conditions, write some notes there in your data sheet. But try to pick a calm day when the wave action on the water isn't going to impede your ability to look down through the water and see your Secchi disc. And then we also ask that you don't measure on days with heavy boating. So this is antithetical to what I said earlier about going out on Saturdays. I know weekends are often very heavy boating activity days on your lake, but as much as possible, like avoid 4th of July weekend if you can, because that heavy boating can really impact the amount of sediment that's kicked up in the bottom of our lake and impact our transparency. And then, as I already mentioned, if you're in a shallow lake that's very clear, make sure to note if your Secchi hits the bottom of the lake. If you're not sure if it hits the bottom, sometimes if you have a deep lake and you can, see all the way through it, and or maybe you're dropping it in and you hit a bunch of plants and you're like, oh, I think I've lost the tension on that Secchi. Note that too. We want to be conservative with this if we think we've hit the bottom of our lake. Just here's another view of our data sheet. Just a reminder of those date intervals and the different pieces of our data that we want to be writing down. On the back of our data sheet, this is what the back of our data sheet looks like. We ask that you draw a picture of your lake on your data sheet, and then put an X approximately where you're sampling. This is just so that we can sanity check that you're sampling in the right spot. So we give you that latitude and longitude of the deepest point in the lake. You can plug that into Google Maps, pull it up on your phone, get a good sense for where you need to be going. But by drawing this map and then putting that X there, that just helps us verify that you are actually in the right place. You're also welcome to print off a map of your lake. Like I know some folks have bathymetric maps, so the maps with all those lines that show you the depth in the lake, and put an X on that and staple it to your data sheet if you'd like to do that. But just some way for us to know that you are close to where we think you should be. We really encourage all of our volunteers to use our online data entry system. There's instructions of how to do that on our website. This is really, really, really helpful for us. Otherwise, if you don't enter your own data, Eric or I and a handful of other folks are doing that data entry, and we do not do it as fast because we're dealing with a lot of lakes at once. So if you would like to enter your own data, we would really appreciate it. You can go to our data exchange page, click the enter data button, and then there's instructions on how to enter your data from there. If this is something you really want to do and you've tried, or you go and try and you can't figure out how to do it, no problem. Just email myself, Eric, Joe, Tamara, any of the instructors, and we'll help walk you through it because we really appreciate you taking the time to enter your own data. We want to make it as easy as possible. This is also a great page to check out so that you can see the data that you've collected. So as soon as you enter your data, this is a really cool function. As soon as it's entered, it's live on the website and viewable for anyone to see. But then we also produce these lake reports that come out at the end of the season, usually the following early spring. So we get all your data entered in the fall of, say, this year, and then in early 2027, your lake report would be available. And this provides a lot of summaries, graphs, interpretation of your data. So if you want to see those lake reports at any time, they're always available on the website. This is also a great way to see historic lake reports. So if you want to see what data were monitored on your lake in the past, and check out your past reports, particularly if you weren't involved in monitoring at that time, that can be a good way to see where your lake is at. As I already said, you'll receive a data report in early 2027. This is what the cover of those reports look like. And then just to review some of the stuff that's in those reports. So here we've got, this is our summary page where we have a lot of graphs. You'll get a graph and some summary data after you've done a couple years of monitoring for different parameters. So looking at the box on our left where we have our Secchi parameter, this is a really nice comprehensive way to see changes in your lake that may be happening over time looking at this graph. So in this case, Quarry Lake in St. Joseph County, they've been monitoring a really long time and really consistently from the 1970s all the way up into the early 2020s. So we have here some summary information about how many individual Secchi readings were taken, both in the primary year of the report. So in this example, this report was from 2022, as well as how many readings were taken over larger periods of time, the average values, the minimum, maximum values, and then graphing out those values onto a graph. On the right is the same thing, but looking at the chlorophyll parameter, which we're going to talk more about in a training later on in the day, in the afternoon. This page is also included in your reports. So this is a really nice way to just snapshot, figure out where your lake falls on this trophic status area. So, as we've mentioned, you've got our oligotrophic lakes, which are really low in nutrients, generally very, very clear, all the way up into our hypereutrophic lakes that have a lot of nutrients in them, a lot of algae growth generally. And so this bar here allows you to see the average. So this is an average trophic value that's calculated based on the parameters that you monitored. So if you only monitored, in this example here, this lake monitored total phosphorus and chlorophyll. Secchi disk is also one of the parameters that goes into this average. So if you only monitored Secchi disk, then we'd be doing this calculation and making an assumption on your average TSI value, or the value at which that helps us understand how much nutrients are in your lake based on that one parameter you monitor. So the more of these parameters you monitor, the better this number is, as far as like having a better understanding of the ecological things that are happening in your lake. But this can be a really nice way just to get a snapshot. What is the lake doing based on the data you collected? And then the reports also include bigger versions of these graphs. So this is a graph that's looking, Portage Lake in Washtenaw County, that's looking at some data, spread out over time. It also shows your standard deviations for those of you that are really into numbers and graphs and values. So the report includes all of this information for you to check out. And again, just really want to emphasize the value of long-term data. So, here's a lake that did some monitoring in the 70s and 80s, took some time off, and then came back and did some more monitoring in the early 2000s. So we can't really make too many inferences about what that lake was doing between those time periods. It looks like, based on this trend line, that our Secchi transparency is improving, is declining. So it looks like it's getting harder to see through the water based on the monitoring data from the early 2000s, but we don't know because we weren't doing any monitoring in between those periods. So maybe it was going up and down, and this is kind of a natural part of that lake's lifespan. So just really want to emphasize that really trying to do consistent monitoring over time. We absolutely understand life gets busy. So maybe one year you monitor a bunch of parameters, and then the next year you can only monitor Secchi disk, or you can only monitor Secchi and total phosphorus. But just trying to get some monitoring data every year is a really nice way to track lake health over time. All right, so we are, let's see here. My computer just froze. Sorry about that. Can you also hear me okay?
We can.
Okay, it's just trying to advance. The next slide is the procedure video. Okay, great. I am going to attempt to play this. And just let me know, Joe, if you can't hear it. Otherwise, I'll assume it's working.
Will do.
Hi, my name is Tamara Lipsey, and I'm an aquatic biologist with
We can, but it's not very loud, so maybe turn up your audio a little bit.
Okay. Tell me how this is.
Today, we are going to demonstrate
That'll work.
Uses Secchi disk to measure water clarity in lakes using the protocol from the MiCorps Cooperative Lakes Monitoring Program. Plan to measure water clarity every week, or at a minimum every other week, from mid-May to mid-September. Plan to take your measurements between 10 a.m. and 4 p.m. Taking a measurement at any other time may result in an inaccurate measurement. Before you head out on the lake, make sure you assemble all the necessary equipment, and fill out your data sheet on the front and the map of the lake on the back. You will need your Secchi disc, safety equipment, data sheet and clipboard, pencil or permanent ink pen, and an anchor in case it's windy. Once you have your equipment, proceed to your monitoring location, which should be over the deepest part of the lake. If there is any wind, the Secchi disc will not go straight down, and you will not get an accurate measurement. In this case, drop your anchor right before you get to your sampling location and drift in. Now remove your sunglasses and move to the shady side of the boat and begin to lower the Secchi disc into the lake until it disappears. Note the depth from the top of the water. Then raise the Secchi disc until it reappears and note that depth. Average these two numbers to the nearest half foot and write this number on your data sheet. If your lake is clear and shallow, your Secchi disc may still be visible while sitting on the bottom of the lake. In this case, record the depth on your data sheet and write "on bottom" in the unusual conditions column. And there you have it. You have measured Secchi disc depth. To learn more about the MiCorps Cooperative Lakes Monitoring Program, visit us at micorps.net.
Maybe I'll just quickly, review some of the questions that happened while you were talking, just so they're in the recording as well. One of the question was where to find your field ID number. And actually, we had an outdated link in the presentation. And so we don't keep that list on our website anymore because it changes all the time. And so if you don't know what your field ID number is, or if you're not sure, sorry, I don't have my video on. If you're not sure where your deepest spot in your lake is, it's easiest just to reach out to us and we can help out and get you that information. We also shared a newer link to the individual lake reports. And if you were involved last year in 2025, we just recently mailed out those reports if you paid for a hard copy. So if you haven't got them yet, they should be in your mail very soon. We had a question about where to purchase a Secchi disc, and does it matter where we purchase it? You can purchase it when you enroll through a MiCorps. We do sell them, and they're really nice, high quality discs, and they're attached to a measuring tape at this point. And so you can just look at the measuring tape and know how far down your measurement is. But what's most important, you can buy them from other suppliers if you wish, or get them if you know someone who has one in their closet. You just want to make sure they're 8-inch diameter discs. 8 inch is the standard. It helps if they're weighted because you don't want them drifting around. You want them to sink down as you lower them. And they need to have those black and white quadrants painted or marked on that.